All right, so hi everyone. Welcome to what I lovingly like to call the BADMIN project. So, there we go. So, alternatively called Na-na-nanana BADMIN. Yeah, because BADMIN, because BADMIN, space, Batman, sound a lot alike. Whatever. I thought it was cute. I'm Gillis, for those of you who don't know me. I'm an AppSec engineer over at White Hat, analyze around 4,000 sites weekly. I've been in it for around 3 years or so, and I was one of the first people to turn in a bug bounty on Google+, and I've received quite a bit of money from the Facebook bug bounty, which is awesome, by the way, and if you don't play with it, you should. And I make developers sweat, and not in the, hey, you're kind of sexy, I'm getting turned on, but, in the, holy shit, you just broke my application. I'm going to cry now. This is who I work for. We do all kinds of software as a service and whatnot. All right, so first of all, you hear a silly name like BADMIN. What do you think? You think, holy crap, someone came up with a horrible catchphrase for a horrible terminology. Well, it means bad admin. And a bad admin is basically a web application developer who, through either laziness or ignorance, doesn't alter the default configuration of their CMS install. Now, it can also be the actual CMS developer who, how many of us actually think that including hard-coded backdoor passwords into into something that's used by millions and millions of people is a good idea?
It's an awesome idea.
Huzzah! All right, so if you include hard-coded passwords into your CMS, you automatically fail. I'm sorry, but you lose so much respect. Or hard-coded passphrases for administrative functionality. Is it really a problem? Now, you'd like to think that as an industry, we've gotten the message across that at least, you need to change the default file path for your logins, for your admin logins. No. Just for /admin and admin login.php, there's over 10 million records on the internet that are indexable by Google. This isn't including customized strings such as /peer, /renovatio, or any of these others unique names. They're still defaults. Now, are these good targets? Now, there's a lot of discussion of cyber war and all this other stuff, but in state versus state warfare, this is the type of recon you do. You would do, a search for a specific top-level domain. And with China, there are somewhere around 2 million results. Now, an interesting fact, anytime I search for this string, plus either .cn or .ir, China or Iran, Google would automatically make me do a CAPTCHA for any requests. So it makes me wonder, just as an aside, if there is a government agency out there doing massive amounts of searches for foreign targets. So what can you get just through a URL? Now, a a lot of us know this, or at least I expect you do, but a lot of custom CMSs, they have unique admin logins. So in this case, Peer has a specific default file path and parameter that's passed. Now, if you can hit that, you can pretty well identify the CMS. Even if they've changed the actual page that is returned when you visit there, you can tell what it is. Same with Renovatio, and same with about 35% of the actual database. They have either the CMS name or version number in the actual URL string. Now, basically, what this can do is allow me, as an attacker, with absolutely no effort, just going in and checking for a 200 response from your server for this specific URL string. If I get a 200 response, I already know what you're running without having to do any work. And that can allow me to find vulnerabilities that are absolutely specific to that framework. Now, the project was born out of frustration with, having to spend, 45 minutes to an hour researching this, on every single freaking pen test. If you look back through some of the projects in the past 10 years, there's been a lot of focus on hardware passwords. PhenoElite did an amazing job assembling a hardware password list back in 2007, 2008. It's still maintained, and it's one of the most comprehensive out there that I've seen. But there's no equivalent of that for web application security. So I decided to at least attempt to assemble something along the same lines. Now, where I work is the TRC, the Threat Research Center. On average, we spend 45 minutes to an hour and a half coming up with custom attack vectors. And I wanted to assemble all of that information in one easy-to-use place so that you could reduce the amount of time that you actually have to spend and invest in research by a factor of 5 to 6 times. So, this is my project. This is a little interface that I've come up with. You can see basically all of the individual CMSs listed. There's over 150 actual records in the database. I had no freaking idea that there were this many CMSs out there. And each one of them has a unique configuration, a unique attack methodology associated with it. And they're all alphabetical and whatnot because, OCD and whatnot. Now, there's the admin login URL. And when I say that, this is where the attacker goes by default to access the administrative login functionality. So sometimes it's accessed by a specified port, but other times it is just simply a resource parameter added onto the end of it. Now, Hippo CMS, for example, uses if you're just trying to append /CMS to the end of it, typically it won't work. However, if you append port 8080 to the end, you get access to the admin login. Now, occasionally, so with a CMS such as Bricolage or Cascade, you'll log in the same spot as all the other users. Now, there's also the username password. What I've included is the username password combo of the highest privileged user that is included by default so that you can get the most access possible with the least amount of research required. And in rare cases, if there are authentication bypasses available, I include links to those, so you don't have to worry about actually authenticating. You can just do whatever the hell you want. Now, I also include additional documentation, so you have an easy one-hit source of all of the configuration options that are available to the administrators of the application. And there's also the known exploits link at the very bottom of the page. I've elected to use exploits download because I also use OSVDB, but unfortunately, it seems as if OSVDB isn't as comprehensive with web application like CMSs and whatnot, which is unfortunate because they're the superior platform. I'd like to see them go at least focus a little bit more on web applications. And it's a good starting place to find weak spots in the actual coding of the application. So even though certain vulnerabilities may have been patched, you can see where the logical fallacies lie in the actual coding of the application. Is the developer lazy in their encoding methods? Do they not care about authentication? Are you able to supply your own cookies or whatever else? Now, just a quick analysis of some of the records I was able to find. The most common default in 2012 is still admin. Case sensitivity, that is the exception. It is not the rule by any means. Even applications that like to say that they are case sensitive, oftentimes you're able to completely reverse the case sensitivity set. So say the first character is capitalized. Instead of doing that, making it lowercase and all the other characters capitalized. So it's checking for the difference, not the actual string. Old platforms, holy crap. There are platforms on the list which date back to 2001. They're not in wide usage, but they are still in rather significant usage on the internet. Now, of course, the most entertaining default was God password. This was from a CMS called PHP Nuke, or PHP Nuke from back in 2006. That just like Serial said, there's something about sysops that just love to use God. It's the whole default male ego thing. All right, so I've told you a little bit about the actual problem of default admin credentials on the internet, but surely this can't be in like a wide attack vector. So the Utah chief technical officer actually had to resign over this vulnerability. There were 500,000 social security numbers that were taken because of a single default password that allows you to reset admin passwords across the board on their network. Basically, a crew out of Eastern Europe broke in and sold off all of the names, and there was so much identity theft. And basically, their entire security team got canned, and they're having to build it from the ground up. Now, that looks like something from the mid-'90s, doesn't it? Would you be surprised if I told you this was March of this year? Yeah. And the Verizon breach report states that about 44% of their analyzed breaches could be attributed to a lack of varied passwords or easily guessable passwords. Now, there's a distinct difference actually in larger and smaller organizations. Smaller orgs is 44. Larger, it drops down to 9. I think this is rather easily attributable to smaller organizations not thinking they have the actual money to invest in security. You know, you're solely profit driven, you're solely wanting to get bigger, and you don't think about the security of the product. And, you know, how much work does it take to change a password? Like, all it takes is a decent mindset for security. Now, what can an attacker get with a default password? This is from an actual test, a actual client site. I can't say any names, and all of the data has been homogenized. However, let's walk through this real quick. So these strings up here, you'll notice removed illegal value. Now, I was able to get to all of this through a basic authorization prompt with the default lowercase admin, which brought me to a search server called UltraSeek. And it basically controlled 10 to 15 different SQL servers and any associated blacklist, whitelist information regarding that. Now, it tells you exactly what is on the blacklist, what characters, what strings, what literal translations it's doing. And it's useful if I'm an attacker and I don't just want to see what's on your site, I want to actually attack your user base. This is what I'm going to use to actually refine my attack. Also gives me internal IP addresses. So if I use this as a pivot point, I have all of your internal information that I need to launch an internal attack. So in this case, you have the address, the DB name, the host name, any associated languages, et cetera, et cetera. Basically give me all of your specs about your network setup. Also, you go further down, it tells me exactly what server operating system you're running, what patch version, what patch version, what distribution, any distribution comments, et cetera, et cetera. You can guess why that's useful. Now, also, I get a click history of all of your admins. So guess what? I can tell exactly when your admins log in. I can tell when they want to patch. I can tell when your admins were too obsessed with porn that they forgot that they had a server upgrade running. And if they only log in twice a week, guess when I'm not going to be attacking the site? Exactly. Also gave me internal file paths and the actual buffer size of the designated temporary storage, as well as the actual directory listing of the internal file paths. So I got to see exactly where they were storing their temp files and, usefully, where I would need to break out of to get a directory traversal attack. This is where it gets fun. So, of course, I had to censor everything because they were client-specific usernames. However, needless to say, I was able to assign myself admin status over any of the designated SQL servers. I was able to change passwords for any existing users. I was able to remove access, delete accounts, all that fun stuff. And here's the scary part. This little web app had a power button. See that down there? That one little button allowed me to turn off all 15 SQL servers. All 15. It actually executed a cut power command to their server cluster. What the fuck? I'm sorry. It's not the best idea in the world. First of all, if you're a web developer, don't code in a power button, no matter how useful it may seem, unless you have you require your admin to use actual gold flakes to execute the request. And if you find that technology, please let me know. So, also, in addition to that, I was able to disable any and all controls that were actually protecting the site. I was able to disable the blacklist, enable logging. So, in case you weren't aware, oftentimes if logging is enabled on a web application, you can get remote file inclusion simply through URL tampering. So if you're able to pollute the actual log files that are being executed, you're able to break out of the echo point and actually execute anything you want. So you're able to disable SQL injection protection, enable directory traversal, allow attackers to access other default locations, and check this out. Down here, that little string there called SSL key list. Yeah, that gave me the entire SSL key list, SSL passwords, the SSL port, the email address of the sysadmin, and all kinds of other useful things. Oh, is that a network user domain username? Why, yes it is. All right, so the takeaway from this that I want you all to take is, first of all, change your frickin' passwords. It's not that hard. Second of all, if you want to do a actual test with the stuff and the things and whatnots, it's whitehatsec.com/badmin/badmin.html, which will take you to this. This is my little live tool that you can go to and find the actual defaults. I'm currently working to go through and convert it to an XML form so you can actually import it into any tool that you want and basically use it to do some very rudimentary fingerprinting of CMSs. Nothing along the lines of WordPress scan. I haven't gotten into version information on the specific actual CMSs, but just to show you how it works real quick, scroll down and there's all of these different CMSs, and for example, if you go to, let's go to PHP/, you get the you can get this is one where you can actually bypass the authentication, but you'll see you click on it, drops down, you get the admin login, username, password, and in this case the additional URL, which is the actual authentication bypass for the application. get the comments. Sometimes there will be proprietary encryption algorithms that use a static key. In this case, the site key that they use by default is PHP weblog, and the exploits link, which is the actual URL for any exploits. And yeah, if y'all have any questions or would like to talk to me or call me an asshole, I'll be around. Thank you.